In the ever-evolving landscape of renewable energy, wind power stands as a stalwart champion, harnessing nature's inexhaustible force to drive our cities and industries. Yet, as the wind energy sector surges forward, a pressing challenge looms on the horizon: the recycling of windmill blades. With that, let's look at wind's last stand, conquering the final frontier of power generation. Can you imagine a world where playgrounds, bridges, and bus stops owe their existence to an unexpected source? What source, you may ask? The very blades that once harnessed the power of the wind. Yet, as these towering structures reach the end of their lifespan, a pressing question emerges. What becomes of them? Surprisingly, these windmill structures share a common origin. They're all crafted from blades. The aesthetic appeal is evident, but there's more to this story. The dilemma arises when these blades reach the end of their life cycle, leaving us grappling with the question of how to handle them. Recycling turbines is a well-trodden path, yielding impressive results. Up to 90% of a turbine can be repurposed, extracting valuable materials like copper and steel. However, the challenge lies in the enormous blades, which primarily find themselves relegated to landfills. This situation has given opponents of wind energy an opportunity to voice their concerns, branding it as a massive windmill scrapyard. But the wind industry isn't sitting idly by. They're on a mission to revolutionize wind turbine blade recycling, not only for environmental reasons, but to safeguard their green image as well. As the wind energy industry continues its exponential growth, the question of what happens to aging windmill blades has become a focal point of concern. Comprising composite materials that are notoriously difficult to recycle, these blades pose a formidable challenge to traditional waste management systems. Landfills are ill-equipped to handle their colossal dimensions, and incineration raises environmental red flags. This burgeoning problem demands an innovative approach, one that balances the need for sustainable solutions with the rapid expansion of wind energy installations. In the face of this challenge, researchers, engineers, and environmentalists have rallied together to confront the issue head-on. Innovative methods such as repurposing blades for alternative applications, converting them into construction materials, and exploring advanced recycling techniques hold the promise of ushering in a new era of sustainability in wind energy. By identifying applications outside of their original context, the industry can extend the lifespan and value of these materials. For instance, retired blades can find new purpose in the construction sector, where their durable composition can be utilized to reinforce structures or even serve as building components. This not only reduces the demand for virgin materials, but also offers an eco-friendly alternative. Moreover, the exploration of advanced recycling techniques presents an exciting frontier in the quest for sustainable wind energy. These cutting-edge methods go beyond conventional recycling processes, aiming to extract and reclaim valuable materials from retired blades. By leveraging technological advancements, the industry can significantly enhance its recycling capabilities, potentially recovering a higher percentage of the blade's composite materials. This not only addresses the immediate challenge of disposal, but also contributes to a more circular and resource-efficient approach to wind energy production. Overall, these innovative methods hold great promise in revolutionizing the sustainability landscape of wind energy. By finding creative and resourceful ways to repurpose and recycle turbine blades, the industry is poised to make substantial strides toward a greener and more environmentally responsible future. This concerted effort not only benefits the industry's environmental footprint, but also sets a precedent for sustainable practices in renewable energy production on a global scale. These endeavors not only address the immediate crisis of blade disposal, but also open up new avenues for reimagining how we utilize wind energy infrastructure. The Colossus in the wind, the world's largest windmill blade. As we forge ahead in the realm of wind energy, one notable feat emerges: the creation of the world's largest windmill blade, boasting a rotor diameter surpassing that of the Statue of Liberty's height. While this is an extraordinary example, it underscores the sheer scale and sturdiness of these structures, designed to withstand the harshest weather conditions for decades. Wind turbine blades, predominantly composed of glass or carbon fibers bound by epoxy resin, yield a remarkably robust material. However, when it comes to separating these components for recycling, challenges abound, leading to the accumulation of retired blades. This monumental achievement in wind energy engineering has emerged as a creation of the world's largest windmill blade. A marvel of human ingenuity, this colossal blade dwarfing its predecessors and symbolizes the unrelenting progress in harnessing the power of the wind. Its unprecedented scale not only promises to revolutionize wind energy generation, but also challenges the boundaries of what we once deemed possible in renewable energy technology. Now let's talk about downcycling. Downcycling, an established method for handling retired turbine blades, involves a robust and direct approach. It encompasses either the combustion or chemical dissolution of the plastic component, leaving behind the fibrous material for various applications. While downcycling represents a positive stride towards sustainable waste management, it's important to acknowledge that these processes are energy-intensive. Additionally, they can result in materials that are somewhat degraded in quality compared to their original state. Nevertheless, downcycling serves as a practical solution to prevent turbine blades from ending up in landfills, making it an important part of the broader effort to minimize waste. A more recent and forward-thinking approach revolves around repurposing turbine blade materials for cement production, a process that brings about multiple environmental benefits. By breaking down these materials and incorporating them into cement manufacturing, waste is not only reclaimed, but also contributes to a significant reduction in CO2 emissions. This approach serves as a highly promising alternative to the conventional disposal method in landfills. Notably, companies specializing in waste management, such as Veolia and General Electric, have taken pioneering steps toward implementing large-scale recycling efforts. Their initiatives mark significant progress in the drive towards more sustainable practices within the wind energy sector. In essence, these approaches underscore the industry's commitment to finding innovative solutions for wind turbine blade disposal. By combining tried-and-true methods like downcycling with cutting-edge techniques like repurposing for cement production, the sector is making substantial strides in mitigating its environmental impact. This progress not only addresses immediate recycling challenges, but also aligns with broader goals of reducing emissions and minimizing waste. Yet the wind energy industry continues to push boundaries, aiming to develop blades that are easily recyclable. Companies like Siemens Gamesa have introduced the recyclable blade, featuring a groundbreaking resin that can be dissolved for material recovery at the end of its life cycle. While these blades are more expensive, they signal a shift towards sustainable designs, albeit with room for further research and validation. In parallel, Vestas, another leading turbine manufacturer, is exploring ways to separate and reuse existing blade materials, including epoxy resin, with promising lab results. Their approach holds the potential to unearth buried blades, offering a second chance for recycling. The quest for sustainable solutions to blade waste remains a vital undertaking for the wind energy industry, shaping not only its image, but also its future viability. This initiative exemplifies the wind energy sector's ongoing commitment to sustainability. The industry recognizes the significance of addressing the issue of blade waste as part of its broader responsibility to the environment. By proactively seeking and implementing recycling solutions, the sector not only burns its public image, but also secures its long-term viability. This forward-looking approach ensures that wind energy remains a front-runner in the transition towards a cleaner, greener energy landscape. Ultimately, the pursuit of effective wind turbine blade recycling is driven by a commitment to sustainability, a core principle for many wind power companies. While the scale of blade waste may pale in comparison to other forms of environmental impact, it serves as a symbolic representation of the industry's dedication to green energy. Addressing this challenge not only upholds the sector's integrity, but also fortifies its position in the transition towards a cleaner, more sustainable energy future. In the face of recycling challenges and the triumphant strides in wind energy engineering, we find ourselves at a pivotal juncture in the pursuit of sustainable power generation. As the wind's last stand unfolds, we are reminded that the future of energy lies not only in harnessing nature's forces, but also in our collective commitment to overcome the obstacles that stand in our way. With innovation as our guiding force, we are poised to conquer the final frontier of power generation, ushering in an era where wind energy reigns supreme.